Hey everyone, just wanted to go over homework number 10, which is correlation coefficient with you guys, and make sure that everybody gets this homework turned in. So you're going to be completing pages 378 to 379 in your workbook. You should be taking a picture and uploading it into Google Classroom. So really quickly, I just want to go over the correlation coefficient scale. As we studied in class, the correlation coefficient is a number that goes from -1 to +1. When it is +1 or -1 exactly, we say it's a perfect positive correlation, meaning 1 to 1. As 1 goes up, as the x variable goes up, the y variable also goes up. And then the numbers 0.8 to 0.99, or the negative values -0.8 to -0.99, we consider those to be very, very strong. All right, when we get to the 0.6 to 0.8, or the -0.6 to -0.8, those are considered strong. 0.4 to 0.6, or -0.4 to -0.6, we say it's moderate. And then below that we have 0.20 to 0.40, positive and negative. Both of those are considered weak. And then anything below 0.2 is considered really, really weak. All right, so let's go ahead and look at question number 1 on page 378. If you want, you should pause the video, take a look at the question before I go over it, and then press play when you're ready to continue. So, question number 1 says, Kieran analyzed his data and found a linear relationship with a correlation coefficient of positive 0.913. Which of the following describes Kieran's findings? So easy, you guys. This is a positive number. So already, number 3 is no good. There's no correlation. No, if it has a correlation coefficient, then there is a correlation. So 4 is silly. So now we're stuck with either 1 or 2. I love that I'm seeing both of these say positive. What about moderate or strong? 0.9? Extremely strong. Best answer choice here would be number 1. Any questions about that? Please leave it in the comment section. Okay, number 2, I want you to pause the video, give it a shot without me, and then press continue when you're ready. Question number 2 on page 378 says Daniela sells shaved ice. She notices that as the days get warmer, she has more customers. Describe the relationship between the temperature and the amount of shaved ice Daniela sells each day. I want us to imagine this on a graph. The x-axis, or the dependent variable, would be her temperature, daily temperature. And then the y-axis, I'm sorry, you guys are used to my handwriting by now, right? The y-axis is going to be how much she's selling. So between the temperature, that's x, and the amount of shaved ice she sells. So let's call this her sales. All right, and I'm guessing she's going to measure that in money. She notices that as the days get warmer, as the temperature increases, she has more customers. So we have a linear relationship with a positive slope. As the days get warmer and warmer, her sales are being driven up. Okay, so I know for a fact number 1 can't be true because that says negative correlation. Number 2 also can't be true. So now we're down to 2 options that say positive, numbers 3 and 4. Look at the difference between these two. Number 3 says with causation, and number 4 says without causation. Do you think it's true that people are buying ice, shaved ice, because they're hot? Is that a cause? Absolutely. So the best answer choice here would be number 3. There's a positive correlation with causation. I'm hot. I need some of Daniela's shaved ice. It makes perfect sense. All right, you guys. I hope that is a good start to the homework for you. I'll go ahead and read question 3, and then I'm going to close out my video. I want you to continue the homework. Question number 3 says a company compares the amount of money they spend. Hold on, I just need to erase this. Oh, sorry about that, you guys. Okay. A company compares the amount of money they spend on advertising to the revenue they earn in sales. The results are shown on the scatter plot below. Okay, so we see our x-axis is the money they spend on advertising. That's increasing over time. And then the y-axis is revenue. It looks as though that's also increasing over time. So the more they spend on money, the more money they spend on advertising, it looks like there's also a positive change in the revenue from sales. Let's look at the question. What can you conclude from the scatter plot? 1, there is a positive correlation between money spent on advertising and revenue earned. 2, there is a negative correlation between money spent on advertising and revenue earned. 3, there is no correlation between money spent on advertising and revenue earned. Or question 4, there is a neutral negative correlation. All right, guys, I hope I've provided you enough of a head start to get this turned in. I hope you guys have a great weekend. Enjoy your day off tomorrow, and I will see you on Tuesday. Bye.